Hello, this is section 3.5, Relations and Functions. Part 1, Relations. A relation is a set of ordered pairs where the first element in the pair corresponds somehow to the second element in the pair. The first component of the pair is called the input of the relation, where the second component of the pair is called the output of the relation. The domain of a relation is the set of inputs. The range of a relation is the set of outputs. Come up with some examples of relations. Relations can just be a set of ordered pairs, and we usually put them in curly braces. So for example, 2 comma 1, -7, -5, 1/2, -5, -7, pi. Or you can have an equation, x squared plus y squared equals 1. That is a relation where the inputs are the x's and the outputs are the y's. Or you can even have a diagram to represent a relation. Where the starting of the arrow is the input, the end of the arrow is the output. We can represent a relation as a list of inputs and outputs, an arrow diagram, a graph, or what have you, depending on the type of the relation. Example 2, state the domain and range of the following relations. So the domain for this one is, again, the set of all inputs. So we have 1, 2, 3, 4, and 5. That is the domain of this relation. And then for the range, we have 1, 4, 9, 16, and 25. For the second example, the inputs are Grace, Kate, and Rose. So those are our domains. And then the ranges, Josh, Eamon, and Allie. Part 2, Functions. A function is a relation for which every input, the first component in the ordered pair, has exactly one output. The second component of the ordered pair. Determine which relations are functions. Explain your reasoning. This is a function. Each input goes to exactly one output. That's why it's a function. This one is a function. Again, for the same reasoning, each input goes to one output. Part 3 is a function as well. Each input goes to one output. Notice how this has the same output. That's okay for a function, as long as this input only goes to one output. Same for that input. Part 4 is not a function. because 1 has 2 outputs. So 1 has an output of 2 and an output of 5. That's why this one is not a function. Now, parts 5 and 6 are a little different because they're in equation form. To determine if an equation is a function, you need to solve for the output variable. And unless told otherwise, the output variable will be y. So let's solve this for y. I'm going to factor this y out. So then we get x squared plus 1 equals 6. To make sure I did it correctly, just think about redistributing the y. Do we end up back where we started? Yes, we do. Then I'm going to divide by x squared plus 1. So I get y equals 6 over x squared plus 1. Now here, if I think about it, when I put in an x value, how many answers will we get? We'll get one answer. So this is a function. Now for part 6, if I solve for y, I'm going to add x to both sides first. Get 5 plus x equals y squared. Take the square root of both sides. You get the square root of 5 plus x. And actually, in case you did not know already, the square root of something squared is the absolute value of that something. Now, if you remember from chapter 2, when we talked about absolute values, to get rid of the absolute value signs, we have to split it up into two equations. So we're going to get 5 plus x equals y, or negative 5 plus x equals y. So when I plug an x value in, how many answers are we getting? We're getting 1, 2 answers. Well, 2 is more than 1, so this one is not a function. Function notation. Each function has a name, like f or g, which denotes the function, but this letter is not a variable. The variable x denotes the input or the independent variable. The variable y denotes the output or the dependent variable. There are two ways we can write a function, either as f or as f of x, which is read as f of x and denotes the function value of f when x is inputted. F of x doesn't mean f times x. Even though that is our notation for multiplication with parentheses, now that we're introducing functions, parentheses can have two meanings now. It can mean multiplication if everything is a variable, or it means this evaluation when one of the letters is a function name. So context will tell you everything in these cases. So example 4, consider the function f of x equals 3x squared plus 2. Evaluate the following and simplify if possible. So f of 2, that means wherever there's an x, it gets replaced by a 2. So we had 3x squared. This is going to become 2 squared plus 2. And then it's just your order of operations. So 2 squared is 4. 3 times 4 is 12. 12 plus 2 is 14. So f of 2 is 14. That's what you do when you have a number. What happens if we have a letter, though? Well, that f of a just means replace every x with an a. So it becomes 3a squared plus 2. Same thing if I put a word in. This will just become 3 squiggle squared plus 2, and that's what we get. Now, f of x plus 2 means replace every x with x plus 2. But remember, since x is getting squared, x plus 2 has to get squared. To indicate when you're squaring more than one term, you have to put it in parentheses. Now, x plus 2 squared means x plus 2 times x plus 2. Do not just square both terms. So then this becomes 3x squared plus 2x plus 2x plus 4 plus 2. Because remember, when you distribute, you have to distribute everything. So that's why I'm getting 4 terms here. And then this becomes 3x squared plus 6x plus 6x plus 12 plus 7. And after combining like terms, we get 3x squared plus 12x plus 19. Example 5. The number of unread emails in Sylvia's account is 75. This number grows by 10 unread emails a day. The function n of t equals 75 plus 10t represents the relation between the number of emails n and the time t measured in days. Determine the independent and dependent variables. The independent, or remember the input, is t, or time in days. The dependent variable is n, or number of emails. Find n of 5 and explain what this result means. N of 5 would equal 75 plus 10 times 5, which is 75, plus 50, which is 125. What this means is after 5 days, Sylvia will have 125 unread emails. And that is the end of section 3.5.